Imagine trying to make breakfast when your arm no longer moves the way you expect. A cup is only a few inches away, but reaching, grasping, and lifting it requires intense concentration. For many stroke survivors, this is part of everyday life. Now imagine learning to control a myoelectric prosthetic hand. The hand responds to electrical signals from muscles, but those signals change with fatigue, arm position, perspiration, and electrode movement. Opening the hand reliably can take weeks or months of repetitive practice. These patients share a challenge. They know what they want to do, but their muscles, movement, and assistive technology do not always translate that intention into function. Access to specialized rehabilitation may also be limited by distance, cost, or clinician availability. SHABRI LLC is inviting students to help develop an AI-driven, clinician-controlled virtual reality rehabilitation platform. The system will combine wearable EMG sensors, movement tracking, artificial intelligence, and immersive functional training. A stroke survivor could practice reaching for a virtual cup, moving groceries to a shelf, or preparing a meal. The platform could amplify small movements, recognize muscle activation, detect compensation, and adjust assistance as the patient improves. A person with limb loss could practice producing consistent EMG signals, opening and closing a virtual hand, selecting grasp patterns, and manipulating objects before or while learning to use a physical prosthesis. The student team will solve real engineering problems, filtering noisy biosignals, classifying movement intent, designing meaningful virtual tasks, creating adaptive feedback, protecting patient data, and presenting understandable outcomes to clinicians. This is more than a software project. It is an opportunity to build technology around real patient needs and to see how biomedical engineering, virtual reality, and rehabilitation science can work together. Your prototype could become the foundation for clinical research, grant funding, and a future rehabilitation product. Help us turn intention into action, practice into progress, and engineering into greater independence.